Okay guys, welcome back. So basically this question is asking you for what is the z value, and that z value is basically the quantile. So, and because we know that if you are dividing the central value to 90%, it means that the tail, so that's usually what these are known for. So the tail are usually basically the remaining probabilities, so that the sum of under all this curve is 1. So this, if the middle is 0.9, the tail here, you just take 1 minus this value and you divide that by 2. It will give you the value for the tail. So 1 minus this is 0.1. So 0.1 divided by 2 is going to be 0.05. So basically you allocate 0.05 here and you allocate 0.05 here. And then the quantile, because this first Q or Z, there's only 5% below it. That's why we call it Q 0.05, and this second Q or the second Z value, there's about 95% below it. So there's 0.9 and then there's 0.05. So that's why we call it Q0.95. And in this case, because we are looking for the value that we're looking for is the Z plus or minus, we use the upper bound because it's going to give us a positive value. I mean, you could have used the negative, the lower bound, but it's advisable to use the upper bound because remember we are using plus or minus to account for those two values already. So we want only a positive value. So that's why it's advisable to use the Q norm 0.95 as you see here. So let me know if this doesn't make sense. So in the third question, now we are asked to use a normal approximation. Using the normal approximation, the probability that sample average of height is less than 169 is. So basically, the approximated probability here, again, we already know how to do this because basically what we're looking for is a probability that the average height. So the random variable is the average of height, and because we know by approximation that average we see that they approximately follow normal. So we know the parameters that was given to us. Well, we know the mu is 170 and the sigma is 1.122. So all we have to do, the probability that it is less than 169, we have to do p norm, which give us a cumulative. As many of you already answered this in your journal, you show that you understand what we do when we use p norm, because you're trying to find the cumulative distribution up to a certain threshold, and that threshold is 169. So that gives us so there's basically about the probability of having a value of height less than 169 is 17.81%. So that's what we get here in question 3. So in question 4, according to the IRS, the average length of time an individual complete the IRS form 1040. Again, everybody who's in the US is familiar with that. It's an important tax form. Is 10.53 hours without attached the schedule, without an attached schedule. So the distribution is is unknown basically. So here now again, this case we don't know what is the distribution for the average length of time. So in some cases, as you're going to see below, we will know the distribution, but we will still use a normal approximation. But in this case, we don't know what the distribution is. And now we assume the standard deviation is 2 hours. So we have the mean. Again, the first thing when you read this exercise, always think about where are my parameters. My mean, which is the population average it could be giving you. And what is my standard deviation? In this case, it's 2 hours. Now we have an n value, which is 36. And compute the average completing time form. So suppose we randomly, basically, we are given an average, the random variable defined by the average length of time to complete the IRS form 1040. And we know from that random variable has a parameters of 10.53, basically the population mean of 10.53 and the population standard deviation of 2 hours. So now we are saying that if we take a sample and we want to see that how accurate the sample is or close to that population, so basically we now try to use an approximation using normal. you need to compute the average time to complete the form. So now we are asked what is the probability that the average is less than 10 hours is approximately equal to. So basically that's what we need to find. So in this case, less than 10 hours. So we want to find the probability. So basically we need to find what are the parameters that go into our P norm. So again, remember P norm, because it's normal, we need a mean, we need a standard deviation. But again, because this is a sampling, we are taking samples. The mean, when you do a normal approximation, when you're taking sample, like when we don't, yeah, when we're taking sample, because remember the previous question, there were no sample into consideration. So that's why we didn't use to use n here, because above we already know the distribution were normal. So that's why we didn't need to like use any sampling here. I mean, in the previous question, but here because we are sampling from an unknown distribution, so the distribution could be unknown, it could be Poisson, it could be uniform, as you're going to see below, but in this case it's unknown. So the standard deviation then is going to have the formula population standard deviation divided by square root of n. So in this case, sigma, or it could be population or it could be sample, but in this case, because we know 2 hours was the standard deviation given, so it's going to be 2 over the standard deviation of 36. So those are the parameters. Those are the most important thing that you need to know before you even start finding the answer that is being asked. And then that is what you use. So again, just trying to explain the solution so that it can make more sense to you guys why we choose these values and why the answer is the way it is. So if you have any question, do not hesitate to let me know in the forum, and I'm glad to provide more explanation if needed. So the second question, suppose that the category of world-class runners are known to run a marathon, 26 miles, in an expectation of 1:45 minutes with a standard deviation of 14 minutes. So now we consider a sample. Again, another thing, whenever you read a problem and you see the idea of sample and you mention to use normal approximation, always remember that you have to divide your standard deviation by, or the square root of the variance by the square root of the square root of the sample, just like you saw here above, divided by the square root of 36. Always remember that when you are sampling and you want to use a normal approximation, the standard deviation is always going to follow that formula. So that's important. So in this case, now we say what is the probability that the runner will average between 1:43 and 1:55, 45 minutes in those 49 marathons. So the most important thing, what are the parameters? Well, we have the mean, so we know what the mean is. The mean is was given to us to be what 1:45. So the standard deviation was given to us to be 14, but because we're doing an approximation, so we have to divide it by the square root of 49. So now we do P norm, 140, the upper bound, 145. So we do the parameter, 145, 14 over square root of 49, minus the P norm again, the lower bound, and we get again, we do the difference. The difference already, as I say, you guys are already familiar with that. So just like similar concept that we've seen previously. So you get the probability. So the probability that the runner will average between 1:43 and 1:45 is 34.13%. So you see, this is a pretty cool concept because it allows you to find probabilities of, I mean, for those who are interested in sport, you can easily start putting probabilities just given some probabilities, some parameters of mean and average. Like you can do a lot of cool stuff with statistics once you, I mean, you know what you need to have in terms of parameters and stuff and things like that. So that's pretty amazing, like what can be done with statistics. So now there is 90th percentile of the for the average of these 40 marathonies. So basically, you try to find the 90th percentile. What does that mean? So you have to, because if you look, okay, let's look at the solution first. So here, so basically here is basically finding the Q norm in a sense, because the 90th percentile means you are going to be in a distribution. Um, so basically Q norm of 0.9 at 1:45, 14 divided by the square. I mean, again, these are because of the parameter of the normal distribution, but because they're asking for the percentile, you just need to enter what that percentile value, the probability that they ask for, which is 0.9 in the formula, and it will spit the value for you.